We have been given three charges plus q, minus q, and plus q, all arranged as shown. We need to find a position where the electric field strength have the greatest magnitude. So to begin, remember the formula for electric field strength is kq by r squared. So let's write down E is equal to kq by r squared. Electric field strength is a vector quantity. For a positive charge, electric field lines all originate away from the positive charge. So let's draw the electric field lines. Before that, let's label all the three charges. So let's say we label A, B, and C for the respective three charges. So consider this charge on A, which is a positive charge. Electric field lines originate away from a plus Q. So we can draw these arrows. So notice electric field lines are going away from this charge A. And we have labeled that as EA, which is electric field due to A. At the point B, there is a negative charge, and we know that electric field lines terminate at a negative charge. Hence, we can draw the electric field lines coming towards the negative charge from both the directions, and we call that as EB, which is the electric field due to the charge kept at B. Likewise, at C, you have a positive charge, and like A, we draw electric field lines going away from the point C. So you can see the two red arrows are going away from the charge plus Q, which is EC, electric field due to the charge kept at C. Now let's find out the individual electric fields at these locations, starting with option A, which is point W. At W, you can see EA is going left, EC is also going left, but the EB is going towards the right hand side. So you can see the green arrow is actually going rightwards. Hence, the net electric field will be EA plus EC minus AB. EA and EC we are adding because the two arrows are in the same direction, and we will subtract EB because it's moving in the opposite direction. Hence, for point W, the net electric field is given by EA plus EC minus EB. Let's apply the similar logic for option B, which is point X. At the point X, you can see this green arrow is going towards the right, which is EB. This blue arrow is going towards the right, which is EA. And this red arrow is going towards the left, right? So it will be EB plus EA minus EC. That's the net electric field at X. Option C is point Y. So similarly, in point Y, you can see the green arrow EB is going left side, the blue arrow EA is going right, and this red arrow is also going left side. So EB is left, EC is left, and EA is right. So we'll get EB plus EC minus EA. Lastly, for option D, which is point Z, you can see EB is leftwards, EA is right, and EC is also right. So we'll get EA plus EC minus EB for the point Z. Now, which of these four options is the maximum? We have to find the greatest magnitude. If you observe carefully, there is a pattern among all these options. There are two positives and one negative. So EA plus EC are the two positives. EB is having a negative sign. So it's the same pattern in each of the four options. Now we have to employ some basic logic. Electric field is given by KQ by R square. So we can write electric field is inversely proportional to R square. Hence, if you have a point which is very close to the charge, electric field will be highest. Out of all these points, you can see the point Y is closest to point B and point C. And if you look at option C, which is Y, you have EB and EC both in the positives and EA is negative. So point Y, B and C are closest and A is quite far apart. So EB and EC will have a large value of electric field. EA will be smaller. In all the other options, the two positive electric fields do not have a great enough magnitude. So for example, for W, EA and EC are both going leftwards, but if you look at the location of W, W is close to A, that's fine, but W is far apart from C. So even though EA will be great, but EC will be small, which means the net electric field at W will be still smaller. At the point X, we can see EA and EB are positive. So look at X. X is equidistant from A and B, but the distance of X from either of these 2 points A and B is greater than the distance of Y from the points B and C, which means EA and EB could be large, but they are not that large as EB and AC for the point Y. Similarly, for point Z, the two positives EA and EC. So let's see for the point Z, EA is coming from the charge at A, which is far apart. So EA value will be very small. EC, on the other hand, is quite close. So EC will be greater. So even though EC is greater, but EA is smaller. Hence, eventually, only in option C, which is point Y, the EB and EC are quite big, which implies the net electric field at the point Y will have the maximum magnitude, which means option C is the answer.